Physics students, good afternoon. Mr. Fugue here. In our video today, what we're going to be looking at are a few problems from your test number 2 review, but these are really just good problems to review for kinematics and as well as projectile motion. Specifically, the two problems we're going to be looking at today cover over directly just kinematics in one direction, whether that's horizontally or vertically. So the problem that we will be looking at is located on your review. That page is also accessible on Canvas if you don't have a copy of it, and there's a key for the problems there. So I'll read us our problem statement and then we'll get started. This is test number 2, review. Just in terms of where you can find this problem written out. And we're going to look at problem number 1. So problem number 1 says this. A car accelerates from 20.5 meters per second to 25 meters per second in a time of 4 seconds. What is the acceleration of the car? So with any kinematics problem, I'm going to skip drawing a picture just so we can save some time here. I'm going to list out my variables. Delta x, initial velocity, final velocity, acceleration, and time. I'm not going to go through and put all of my subscripts on the variables because here we're just looking at a car traveling horizontally. So we don't really know anything about delta x, how far we go, but we do know we start at 20.5 meters per second and we accelerate up to 25 meters per second in a time of, I believe, 4 seconds. We're looking for what is the acceleration of the car. So if I look at my kinematic equation sheet, where does delta x not show up? Well, that should be in equation number 1, which looks about like this. V1 is equal to V0 plus acceleration times time. This is equation 1 from our kinematic equation sheet. Extra copies of that sheet are also on Canvas in case you need to access them. So now we'll go through and plug in our variables. Final velocity was 25 meters per second. Initial velocity, 20.5 meters per second, plus acceleration. I'm going to leave that as the a variable in our equation because we don't know what it is. And time is 4 seconds. Now here, we want to get this a variable by itself. So I'm going to start by subtracting my value, 20.5, to the opposite side of my equation. Remember, I can't combine 20.5 and 4 because I have this a variable, which I don't really know what it is, so I can't combine those. So 20.5 minus 20.5, those will cancel out. 25 minus 20.5, a little bit confusing to say, should be 4.5, and those are seconds, meters per second, because they're velocities, is equal to a times 4 seconds. So now, just a matter of getting a by itself. Scroll down just a little bit here. Now we want to get a by itself, so we'll divide by 4 seconds on both sides of our equation. 4.5 divided by 4 gives me an acceleration of about 1.125, or if we're going to round to 3 significant figures, 1.13 meters per second squared. So again, a basic kinematics problem, listing out our variables, identifying what we know, and using that to determine our equation, and then plugging in to solve for the desired answer. So hopefully that gives us an idea on solving a basic one-dimensional kinematics problem. Now we're going to look at problem number 2 on your review, which will involve an object traveling vertically. Problem 2 says this. A standard marble launcher launches a marble 3.45 meters directly up. Determine the launch velocity or initial velocity of the marble. This is similar to a lab we will be doing in class. So here, I'm going to list out my variables, delta y, v0, v1, acceleration, and time. I am going to put here acceleration in the y direction so we can remember what direction we're talking about. Now in our problem, we're essentially taking a marble, we're launching it up to a height of 3.45 meters, and it's going to come back down. Now what we are looking for is how fast the marble is launched, or its initial velocity. So I'm going to put a V0 by, or excuse me, I'm going to put a question mark by V0 because this is what we're looking for. We are told that the marble launches up to a height of 3.45 meters. So that's going to be our delta y here. And we will keep it as a positive value because we're launching our object straight up. I'll erase this to make a little bit more space. There we go. This would be our delta y. Now, because we're dealing with an object moving vertically, we can assume our acceleration is just acceleration due to gravity, so negative 9.81 meters per second squared. Again, that's an assumption we have to make because we're moving vertically. We stop here. We should notice we don't have enough information to get what we're looking for. In order to solve a kinematic equation, we need at least 3 variables to find our fourth, if we're just going to use one equation here. So, here's the other thing we have to be aware of. Once we've traveled 3.45 meters from where we start to our peak, think about what happens at that point. As we've talked about in class, anytime an object changes directions, it momentarily has to stop. Even if it's just an instant. Once we've reached our maximum height, our object will stop instantaneously, very quickly, which means at this height, at our maximum height, our velocity in the y direction will be 0 meters per second. And that's an assumption we have to understand that we are making here. Now that we know that, the thing that we don't know here is time. Ultimately, we could go back and solve for it if we were asked for that, but it's not really what the problem is asking us here. So if we look at our kinematic equation sheet, time does not show up in equation 5. So we can go here to find our initial velocity. So it will look like this. v1 squared is equal to v0 squared plus 2a delta y. In this scenario, our v1 is 0 because we are stopped at the maximum height. So this would be 0 meters per second squared is equal to v0 squared plus 2 times negative 9.81 meters per second squared times 3.45 meters. Running out of space there, I'm sorry. Need to move this over a little bit. There we go. So now what we can do is multiply through anything that we can. So this becomes 0, 0 squared is 0, is equal to v0 squared plus 2 times negative 9.81 times 3.45 gives us negative 67.69. So again, we're looking for v0. So now that we have most of our work done, we can take this 67.69, add it to the other side of our equation. So plus 67.69. These values will cancel out, and we'll be left with something that looks about like this. v0 squared, we'll write it with our variable first, is equal to 67.69. Now again, logically that probably shouldn't be our final answer. We're launching something about 3.5 meters or roughly 12-ish, maybe 10 to 12-ish feet in the air. It's probably not going to be launched at over 100 miles an hour, which means we need to take a square root to get v0 by itself. So v0, when we take our square root, should be a little bit over 8, about 8.23 meters per second. And that is how we would set up and solve our initial velocity for launching the marble. So again, when we're dealing with the kinematics scenario, let's start our variables, think about what we know. For the y direction, we're oftentimes going to know more than we are directly given, specifically acceleration in the y, and also if we're looking for our maximum height, we know our object has to stop vertically at that point. So hopefully these give us an idea of what we're doing for one-dimensional kinematics, horizontally and vertically. And if you have any questions, do not hesitate to ask. Good luck.